Hi students, in this video we're going to be looking at the start of fractions from Mathspace. That is chapter 2.01, where we're going to learn to name, identify, order and compare fractions. So starting by looking at the lesson on Mathspace. As always, I'm not going to read through this word for word, but I'm going to summarize key points. So here we start by looking at what a fraction actually is. So a fraction is when we take a whole, and we often refer to numbers, but here we're looking at it as a picture. So we have a whole, we're dividing it up into equal amounts, and then we're working out how many of those amounts we have. So in the case of this shape here, we can see it's divided into 1, 2, 3, 4, 5 pieces. So our fraction would be something over 5. And in a minute, we're going to look at what this 5 is called. But for now, the number at the bottom represents how many pieces make up the whole. And then we can see we've got 1, 2, 3 shaded. So the number that we would have at the top of our fraction would be 3. So we would say that's 3 over 5 or 3 of 5. And it basically means we have 3 pieces out of a possible 5 pieces. Okay, and that would represent this shape here. And of course you can do that on a number line. So here we have a number line where it's divided into 2 pieces. A little bit hard to tell immediately. So if I quickly redraw this number line, okay, we have 0 at the moment here. We have 1 being here. These numbers are not important right now. What is important is that this whole, so 0 to 1, is divided into 2 pieces. So this is 1 piece here, and this is 2 pieces there. And the dot that they've drawn, so they've got a blue dot here, is at the center point. So it's really saying we have this part here. So our fraction for that becomes 1 piece over a possible amount of pieces being 2, which we can say that's 1 over 2, or in this case, it's a half. Okay, so that's what those are showing there. So let's scroll down a bit further, and let's now talk about the parts of a fraction. So what do we actually call these different parts of a fraction? So here I already have it written out, so I'm not going to draw it for you again. The number at the top, so in this case 4, is called our numerator. Okay, the number at the bottom is our denominator. So the numerator, the number at the top, tells us how many pieces of the whole that we have, and our denominator tells us how many pieces a whole has been divided up into. So a shape or something that we have, how many pieces we've cut it up into. Now the line in between does have a name. It's called a vinculum, as we can see there. Now, while that term is not as important to remember, it's certainly good to try and remember, but it's not usually going to be shown in the test or anything like that. But it's a great piece of trivia if nothing else, so it's always good to try and remember it. But numerator and denominator are really important, and you're going to need to know those names. Okay, let's scroll down a little bit further, and we're now going to talk about the 3 different types of fractions you'll see. So I'm just going to quickly chuck in another page on my notes here, and we will start talking about that. So there are 3 different types of fractions that you'll see. So let me just draw a couple out quickly for you. So if we had the one we had before, so 3 over 5 or 3/5, okay? Our numerator is smaller than our denominator. So the number at the top, the numerator, is smaller than the denominator. So we call this a proper fraction. Okay, sorry about my bad writing with my mouse. So this is a proper fraction where the numerator is smaller than the denominator. If I had something like 7 over 5, the numerator is now bigger than the denominator, so this is what we call an improper fraction. Now notice it's I am, not improper fraction. Okay, so if our numerator is bigger than our denominator is an improper fraction. Now, as soon as you get an improper fraction, it actually means that you have more than a whole in your numbering there. So if we think about what this actually represents, this represents, in fact, let's go back to the first one. If I had a shape, I'm just going to do a quick little shape here, right? And that was divided up into 5 pieces. Now, obviously, these are not equally drawn. 1, 2, 3, 4, 5. Sorry about my terrible drawing. This means of this whole shape, I have 1, 2, 3 pieces. So 3 of the 5 pieces is what 3 over 5 means, this proper fraction, okay? But if I look at this version here, I have 7 of 5 pieces. So if I was to draw again a shape, and again divide that into 5 pieces, I'll try and do a little bit better this time, tiny bit better. 1, 2, 3, 4, 5, yep, and I try to colour those in. I've got 1 piece of 5, 2 pieces of 5, 3 pieces of 5, 4, 5, but I need 7. So I've got a whole shape now, and I need to have the next one. So here I go again with another whole shape, again still divided into 5 because our denominator is 5. But I've got 5 of them so far here, and I need 2 more to have 7 fives, or 7 fifths, sorry. So there's 2 more. So now I have 1, 2, 3, 4, 5, 6, 7. So here I have a whole shape and 2 fifths of the next shape. And that brings us to our third type of fraction. The third type of fraction is where we actually take this from it being an improper and we show the whole number and the fraction left over. So that number above 7 over 5 can be shown like this. We have one whole number, one whole shape, and 2 fifths still left over. So we call this one a mixed fraction. Right? So we have a proper fraction where our numerator, is smaller than our denominator. We have an improper fraction where our numerator is bigger than our denominator, and an improper fraction can be turned into a mixed number or a mixed fraction where we show the whole part and the fraction part. So these two here are represented by the same image here. One whole and 2 fifths, which is the mixed number, 1 whole and 2 fifths, or 7 individual fifths. So the improper version or the mixed version. Okay, let's scroll down a little bit further and we're going to talk about comparing fractions now. So again, I'm going to chuck another page in, sorry. I'm going to put another page in here. And let's talk about comparing fractions now. So using the example over here on the left, we can easily see that if we have 3 eighths and 5 eighths and we represent them graphically, so the whole is the same size, but in this case it's divided into eighths in both. Here we have 3 eighths and here we have 5 eighths. It's really obvious that 5 eighths is bigger than 3 eighths, right? What I hope you recognize is that works because the denominators are the same. They're both divided into eighths. Okay, so it's very easy then to look at the numerator to tell which one's bigger. But what if we have something like the ones down here where we've got a 6 and a 10? Okay, so let's make up our own numbers quickly. So what if we had 5 over 6, right? And we also then had, let's go with 7 over 10. That's a really bad 10, sorry. Let's try that again. 10. All right. It's not so obvious straight away which of those is bigger. So what we're going to want to do is create equivalent fractions, fractions that are mathematically the same, but what we want is the denominators for both fractions to be equal to each other so that we can just focus on the numerator. So for that to happen, we need to work out what do we need to do to both of these fractions, right, to both these fractions so that the denominator becomes the same. Now the easiest thing is just to multiply by each other. So for this one to have the same denominator as that one, if I multiply this 6 by 10, I will get 60. And if I multiply this 10 by 6, so by the numerator, I will get 60 here as well. That's the quickest and easiest way. Sometimes there are other options. You might be able to divide by a different number or multiply by a different number. but you need to find something that you can do to get both of these the same. Now the trick is, whatever you do to the denominator, you have to do to the numerator. So if I'm going to multiply 6 by the other denominator 10, I'm going to write that in my book like this: 6 times 10, all right? But if I'm going to do that to the denominator, I need to do the same to the numerator. So I'm going to do times 10 there as well. So that is going to be equal to, here's our vernaculum, 6 times 10 of course is 60, and 5 times 10 is 50. So 50 over 60, or 50/60ths, is an equivalent fraction, the same mathematically as 5 over 6. Let's have a look at how we're going to affect this one down here. So for us to get 10 to be 60, because we want the same denominator, I'm multiplying it by this denominator here. So I'm going to multiply that by 6. And again, I have to do the same to the top. So let's multiply that by 6. So what we end up with is 60, so 6 times 10, and 7 times 6 is 42. Okay, so now that we've got the same denominator, so 60 is the denominator here, 60 is the denominator there, we can simply look at the numerator to tell which one is bigger or smaller. So in actual fact, 5/6 is bigger than 7/10. So even though originally the 7 on the top is bigger, when we get them to be equivalent, we can see that 50 over 60, 50 is definitely a bigger number than 42. So we can say 5 over 6, right, is greater than 7 over 10. So we can mathematically show that because we've made them with the same denominator. Okay, so that's the process. So I would expect to see something like this in your book to answer a question which, when it talked about which one was greater. In a similar way, if you've got things with the same denominator, you can go backwards. So if you were trying to simplify this, we could say, okay, what is a number that goes into both the numerator and the denominator? So here again, we know because we just did over here, we could say, okay, we can clearly divide these by 10. So we could do divide by 10, but again, you do the same to the top and the bottom. All right, so again, you'd end up back with 5 over 6. So when you're trying to simplify a fraction to bring it to its smallest size, you're basically looking for the biggest number you can divide both the numerator and the denominator by to bring it down to its smallest amount. Okay, so essentially when we're doing things with fractions at the moment, we have to do the same thing to numerators and denominators all the time. So that's pretty much what we need to look at for the moment. Okay, there's a little summary down here as always. Okay, but that's pretty much what we need to see. So as always, have a go at your questions. If you've got issues with those, please make sure you're asking for assistance, and we will move on to 2.02 in the next lesson.